Good morning, students. So we were learning about the resistance, right? System of resistance. So next one we are going to see the resistors, like how a resistors will be connected in a series. So last class you might have seen the video of it, right? So you might have got a clear understanding how the resistors, the resistors will be connected in a series, how we can tell the resistors connected in a parallel, right? So what is happening, what are the advantages of resistors is connected in series, and what are the advantages of resistors are connected in parallel? When two or more resistors are end to end, the arrangement is called series connection, right? You can see this picture. Please draw the circuit diagrams in your points notebook. See in the diagram what and all it is marked. Battery is marked, plug key is marked, ammeter is marked, and voltmeter is marked. Okay, so you can see the direction of the current also. So it is moves from the positive terminal to the negative terminal. Okay, so when a resistor is connected in a series, okay, so if you want to find the total sum, so according to Ohm's law, what is the formula for finding the Ohm's law? V is equal to IR, right? V is proportional to I. That is the potential difference across the wire is directly proportional to the current, right? So that is V is equal to, Ohm's law is very important. V is equal to IR. So V is determining the potential difference, I is the current, and R is the resistance. Okay, here the resistance, sometimes you want to, they will be given resistors value only, they are given. We have to find the total resistance. So like that, according to the circuit, like whether they are connected in a series or whether they are connected in a parallel. If they are connected in the series, the total resistance, the formula is R is equal to R into R1 plus R2 plus R3. That is total resistance to find out. Okay, that is R1. That is, we know resistors are measured in an SI unit ohm. Okay, the current through the each resistors will be same. Equivalent resistance will be larger in the individual resistance. Here, for that, total voltage will be like a V is equal to V1 plus V2 plus V3. To find out the total voltage. Okay, then voltage across each resistor, if you want to find voltage across each resistor, V1 is equal to I into R1, V2 is equal to I into R2, I into R3, I into like R4 it will come, or we can write it as like a V is equal to, so that when you please go through it, that is V is equal to I is a common everywhere, so we will take it out. I is equal to what? V is equal to V, we know according to the formula, that is V is equal to IR. So I is equal to R1 into R2 into R3. So the R1 into R2 is R, so that is both will be equal. Understanding? So this is what it is telling. It is nothing. I will be explaining you when the school is reopening, and the Monday the school is going to reopen, and the numerical sums of this chapters I am going to explain in the board. So that time you will get better understanding. So that is why I am just giving you an understanding what is these things. So when you come for the class, if I explain, you will get more understand. Okay, you will get more you will understand better than this. Okay, so that is what, just go through it, the numerical sums, and if you have doubt till Monday, you people have to wait. So till Monday, if the school reopen, the government has told to reopen the school on Monday. So if the schools are reopening, so that time I will be explain you better. Okay, in the board by writing I will explain you. So for time being, please understand this. Okay, next, if the resistors are connected in parallel. Okay, parallel, it means one above the other. Okay, so here what will happen, the equivalent resistance to find 1 by R1, it will be in a reciprocal. Okay, 1 by R1 is R is equal to 1 by R1 plus 1 by, that is the total resistance. Total resistance, if it's connected in series, that is R is equal to R1 plus R2 plus R3. If the total resistance they are connected in parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, here the current will be changing. There in the series connection, current will be same and it will not change. What will be changing? Potential difference. But here the current will be changing and the potential difference remains the same. That is the difference. In series connection, current is same for everywhere and the potential difference will be changing. In the parallel connection, what is changing? Current is changing and the potential difference will be remains the same. Okay, so that we will be explaining you. Now I will be uploading one more video so that you can able to understand better. So the heating effect I will be explaining in the next class. Okay, then the numerical sums I will be explaining from Monday. Okay, please try to understand the concept until that. Okay students, thank you.
Take two 1.5 volt AA electric cells. The region with the metal cap is the positive terminal of the cell, and on the opposite side, the region with the flat metal base is the negative terminal. Join the positive terminal of one cell with the negative terminal of the other using electrical tape. This is called a battery. A battery is simply a combination of two or more electric cells connected together in a series combination or a parallel combination. What are these combinations? Well, if the cells are connected as shown with their opposite terminals connected together, then we say that this is a series combination of cells. We simply say that the cells are connected in series. Parallel combination is when the positive terminals or the negative terminals of the cells are connected together. However, we are only interested in the series combination of cells. In everyday life, we call this single cell a battery. But in physics, a battery is a combination of more than one cell. So this is a battery with a positive terminal on one side and a negative terminal on the opposite side. We can even connect more cells to the system, but always make sure that the positive and the negative terminals are connected together. Even if 4 are connected together, it will still be called one battery. Now let's talk more about a battery. What is the voltage of a battery of combination of two cells? Well, if the cells are connected in series, then their voltages add up. This means that the voltage of this battery will be 1.5 plus 1.5 volts. It's the sum of these two voltages. What will this be equal to? It will be 2 times 1.5 volts, which equals 3 volts. So this battery is twice as strong as one individual cell of that battery. But wait, it does not mean that this battery will last twice as long. So what does it imply? We first need to understand that different devices require different voltage power sources for functioning. The torch bulb in our torch requires a 3-volt battery to light up brightly. This is why the series combination of cells is used in a torch. If you remember, this is how you insert cells in a torch so that opposite terminals are in contact with each other. We must have also seen battery compartments in devices in this shape. How do we insert cells in this cell holder? Yes, we compress the spring by inserting the negative terminal of the cell. What is the spring made up of? It's made up of metal and hence it conducts electricity. On the opposite side, the positive terminal of the cell is also in contact with some metal thing. In the same way, we insert the second cell. But are the cells connected in a series combination here? Looks like a parallel combination, right? No, they are in a series combination. If we carefully look at one end inside an empty cell holder, we will find a thin metal wire or a metal rod connecting the positive terminal of one side with the negative terminal on the adjacent side. So that is how the cells inside this container are connected.